The formation of the Sun and the planets is a result of the same cosmic processes that led to the creation of galaxies. The leading scientific theory for the formation of the solar system is the nebular hypothesis. According to this hypothesis, the solar system formed from a vast, rotating cloud of gas and dust called the solar nebula about 4.6 billion years ago. Here's a step-by-step explanation of how the Sun and the planets were created. The solar nebula. The solar nebula was a giant, diffuse cloud composed mostly of hydrogen and helium, along with traces of heavier elements. It is believed to have been created from the remnants of previous generations of stars that went through their life cycles and ejected their outer layers into space. Gravitational collapse. A nearby event, such as a supernova explosion or a shock wave from a passing star, likely triggered the collapse of the solar nebula. This triggered the cloud to start contracting under its gravity, causing it to spin faster and flatten into a rotating disk. Protostar formation. As the cloud continued to collapse, the central part became denser and hotter. Eventually, the temperature and pressure in the core reached a point where nuclear fusion reactions began. This marked the birth of the Sun as a protostar. Protoplanetary disk. As the protostar formed in the center, the remaining gas and dust in the flattened disk around it began to clump together due to gravitational attraction. These clumps of material, called planetesimals, grew larger over time by accreting more gas and dust. Planet formation. In this protoplanetary disk, small solid particles began to collide and stick together, forming larger bodies known as planetesimals. Through further collisions and accretion, these planetesimals continued to grow into planets. Terrestrial and gas giant planets. Two main types of planets emerged in the solar system. Close to the Sun, the high temperatures and solar winds prevented the accumulation of light gases, resulting in the formation of the rocky, terrestrial planets: Mercury, Venus, Earth, and Mars. Farther from the Sun, in the colder regions of the disk, there was enough material to allow for the accumulation of both rocky cores and abundant gases, leading to the formation of the gas giants: Jupiter, Saturn, Uranus, and Neptune. Solar wind. As the Sun's nuclear fusion reactions intensified, it started emitting a solar wind, a stream of charged particles. The solar wind cleared the remaining gas and dust from the inner solar system, leaving the rocky planets in their current positions. Final arrangement. The formation of the planets and the gravitational interactions among them led to the final arrangement of the solar system we observe today, with the Sun at the center and the planets orbiting around it. The formation of the Sun and the planets was a complex and gradual process that took millions of years. The study of other planetary systems around distant stars, called exoplanetary systems, has provided additional insights into the processes involved in the formation of solar systems. However, the exact details of the solar system's formation continue to be an active area of research and exploration.